and welcome to the Cisco support community. Today, we present another exciting live Ask the Expert event inside Cisco Live and Networkers Virtual. During our event today, our expert will be answering your questions on dynamic multipoint VPN. My name is Daniel Gerson, and I am the content manager for Cisco Live and Networkers Virtual here at Cisco. Our expert joining me today is Mike Sullenberger, a distinguished engineer here at Cisco San Jose.
Hello, everyone.
Mike will provide insight and design and positioning of DMVPN networks. Now, I'd like to briefly outline the format for today's Ask the Expert event. Mike will start with a short presentation on DMVPN for the first 35 minutes of the program, and then we'll dive into the live question submissions for the remainder of the event. During our live presentation, you may submit a question to be answered by Mike and a team of Cisco technical experts using the submit box on the left side of your console. Simply type your question and press submit. To see the latest questions and answers during today's presentation, be sure to click the refresh button just under the slides. You can scroll up to see the previous answers in the Q&A box. The team of technical experts is well versed in DMVPN, so please start posting your questions now to give us the best chance of answering them. We'll also be asking polling questions during this webcast, and we encourage you to participate by answering them. Now, let's get started with today's event. We'll start things off with a polling question. What type of IPsec VPN have you recently designed or wanted to design? EasyVPN, DMVPN, GetVPN, or you're not sure which one to use? Go ahead and take a moment to answer, and then we'll view the results. Okay, let's have a look at these results. Okay, it looks like DMVPN, the winner by 52%. Now I'd like to hand the mic over to Mike, who will provide insight on DMVPN design. Go ahead, Mike.
Thank you very much, and welcome, everyone. So today I just want to go into a little bit, go over a little bit of the Cisco IPsec VPN technologies. Sort of that's what that first question was related to. And then a little bit about what is DMVPN, just, very brief overview. Then talk a little bit about scaling DMVPN and then DMVPN network topologies. The idea of today is just sort of, I'm looking for a VPN for my network. What type of VPN should I use? Dynamic multipoint VPN or DMVPN looks good. How would I design it to fit in my network? Or what are some of the things I need to look at for that design? So let's go ahead and get started with that. So here is VPN technologies that we support. The next two slides sort of go through the difference between enhanced EasyVPN, DMVPN, and GetVPN. That's our three main VPN technologies that use IPsec. And I'm not going to go through each point here on this. I know there's a way for you to download these slides, and I highly recommend that you go ahead and do that so you have this information for your use later. But in general, when I think about DMVPN, enhanced EasyVPN, and GetVPN, I sort of think of them in this way. They don't directly compete with each other. So they pick up different sections of your network, or they handle different network types. EasyVPN is primarily remote access, but it does handle some site-to-site capabilities. DMVPN handles all forms of site-to-site capabilities, okay, but it doesn't do remote access. So there's a little bit of overlap between EasyVPN and DMVPN at certain site-to-site type capabilities. And then GetVPN is an encryption technique that encrypts an already created VPN. DMVPN, in contrast, creates the VPN and encrypts it. So DMVPN has tunneling capabilities built into it, and it encrypts that. GetVPN doesn't have tunneling capabilities built into it. It's designed to encrypt a VPN that's already in place. And a major example of that would be like you already have MPLS running. So that's already created the VPN for you. We then use GetVPN to encrypt the traffic going over your MPLS network. And we actually designed GetVPN in mind for MPLS because it is more efficient on an MPLS network than DMVPN. So even though DMVPN and GetVPN overlap, GetVPN may be the better choice in some network designs. So here's the second slide of this. As I said, you can go through these and see the differences in the different technologies. So I want to go on. And so just a little reminder for people that may not know exactly DMVPN. The way I think about DMVPN is that it's basically a tunnel building, or it builds a dynamic tunnel network. That's what it's designed to do, build a dynamic tunnel network. And it uses multi-point GRE tunnels on the routers and, NHRP, Next Hop Resolution Protocol. You can think of NHRP as a fancy ARP protocol. Like on an Ethernet, you connect a lot of nodes, routers or hosts to an Ethernet. They need to talk to each other. They have an address resolution protocol, ARP, in order to map so they can find each other and send packets to each other. NHRP is basically the same thing, running on top of a tunneling or GRE tunneling protocol. Does the same thing, a little bit fancier than ARP over Ethernet, but it's providing the same basic functionality. Some of the major features for DMVPN. Actually, the first one on the list here, configuration reduction and no-touch deployment, that was the main feature when I designed DMVPN going on about 10 years ago when I first had the ideas for DMVPN. At the time, we were using point-to-point GRE tunnels with IPsec, and I was noticing in a network of maybe 300 nodes where you have like 300 spokes and 1 or 2 hubs for a spoke and hub setup, that the hub may have like 5,000 or 6,000 lines of configuration in order to support that. With DMVPN, we're able to reduce that configuration load down to like 50 lines on the hub router because everything is dynamic, everything's done underneath. You still have 300 tunnels, 1 to each spoke, but you don't have to pre-configure that information. DMVPN supports IP unicast traffic, IP multicast, and dynamic routing protocols. So basically, DMVPN, in building this dynamic tunnel network for you, is more like an extension to your network. It's like a virtual WAN almost. I mean, that's the way you can actually treat it. You can run routing protocols over the links or the tunnels, etc. Remote peers can have dynamically assigned addresses. So if I have spoke routers that are DSL connected or cable modem connected, for instance, where their ISP gives them their address, their physical address on the fly, DMVPN supports that. As well as maybe your ISP gives you a RFC 1918 address, a private address, and then he NATs you when you go out to the internet. Again, because of the dynamic nature of DMVPN, we can support this. DMVPN came with it, or NHRP supports the concept of dynamic spoke-to-spoke tunnels. In a base DMVPN network, we build out a base hub and spoke network. Spokes connect into a hub. With the dynamic spoke-to-spoke tunnels, if I have traffic from spoke 1 to spoke 2, instead of having to send the traffic from spoke 1 to the hub and then the hub back out to spoke 2, DMVPN can find and build a direct spoke 1 to spoke 2 tunnel and send the traffic directly bypassing the hub. You can use DMVPN without IPsec encryption. 99% of DMVPN networks out there do use encryption. There's a couple, usually defense departments, that may turn off IPsec encryption because they have better hardware encryptors that they want to use, but they like what DMVPN does for them by taking their data traffic and putting it into tunnels, and then they present the tunnel to their encryptor. It saves load on their encryptor. DMVPN works with MPLS and VRFs. DMVPN can run over MPLS. We can run MPLS on top of DMVPN. We can use VRF Lite combinations. So all of these combinations with DMVPN, you can build a fairly complex setup. We do support QoS. We can do aggregate. QoS on the spokes means all the tunnels, we sort of measure them in aggregate. This says static manual per tunnel. That's actually slightly old. We came out with a per tunnel QoS, which is dynamic for the hub to spoke traffic. So we can actually set up QoS individually per tunnel in the hub to spoke direction. Transparent to most data packet level features. What I'm saying there is that because DMVPN presents to the router an interface, pretty much anything that's interface-based, which is most everything on a router, will just run over DMVPN. It's pretty transparent. And then finally, a wide variety of network designs and options. And towards the end of the talk, I think we'll see, sort of the designs and network options that we work with on that. So the DMVPN phases. So we often talk about different phases, phase 1, phase 2, phase 3. In general, phase 1 is hub and spoke only. Okay, we're not turning on the dynamic spoke-to-spoke tunnel capability. Phase 2 is dynamic spoke-to-spoke functionality. Okay, and phase 3, as it says here, is again dynamic spoke-to-spoke functionality. Now, we originally implemented phase 1 and phase 2 pretty much about the same time. Code went out. What we found, and when we implemented that, we had a number of bugs. Some were hub and spoke related, some were spoke to spoke related. So this is, I'm talking back about 6, 7 years ago. So we decided we would fix a bunch of the bugs for the hub and spoke, call that phase 1, and then basically immediately turn around and fix the generic spoke-to-spoke bugs we had at the time and call that phase 2. So you can see those basically came out at, at the same time. We fixed all of them at the same time, but we still sort of refer to phase 1, phase 2. Now, the way that we implemented spoke-to-spoke tunnels under DMVPN phase 2, it came with a number of restrictions and caveats. You had to set up your network just right. You could only have a one level of spoke to hub based structure. There's a lot of caveats, a lot of restrictions. So we said, well, we need to get rid of these restrictions to be able to scale DMVPN networks to larger sizes. So we came out with phase 3. Phase 3 is basically the same functionality as phase 2. Dynamic spoke-to-spoke tunnels. We do it in a different manner. But because we do it in a different manner, we're able to remove most of the restrictions and complexities of phase 2. Easier setup, you have less restrictions. We can have multi-layer hub and spoke or hierarchical hub and spoke setups. A whole bunch of other stuff opened up because we went to phase 3 and gave us a lot more flexibility in designing the DMVPN network. And as you can see, that is supported from 12.4.6T on all the ISRs, the 7200s, et cetera. The ASR is supported in release 5 on that. So that sort of gives you an idea when we talk about phase 1, phase 2, what we're really talking about. One of the critical things for DMVPN is the DMVPN Hub. So the hub is a critical node because the spokes are set up, they're pre-configured with the information for the hub. So the spokes will dynamically connect into the hub. They authenticate with the hub accepts them in, builds them into the network, runs a routing protocol with them, and they're all part of, everything's all folded into the network. But that hub is a critical node. You lose that hub node, and the DMVPN network goes down. And that's one reason why we always recommend at least 2 hubs. Spokes can attach to any number of hubs. We do recommend a minimum of 2. So you go, okay, so the hub is an important node in the network. So where do I put it? So the recommendation is there's 2 things the hub does. It is a data plane aggregation point, and it is also a control plane aggregation point, because that's what NHRP is, like the center of the NHRP database system. So what I usually do is I try to place my hubs at a place where I want to access data, I guess is the way to say it. So often it's at a data center. Okay, so if I have a lot of spokes out there, a lot of nodes out there that want to connect in, and they want to access, usually they want to access some big database or some data center to do functions for them. So I usually like to put the hub there because the spoke hub tunnels, those come up immediately they're not traffic driven. They come up immediately, and they stay up all the time. So they're already pre-built. So using them, so it's good if most of your data traffic actually uses your spoke hub tunnels. Your spoke-to-spoke tunnels, those only come up on demand when we actually have data traffic to use them, and then they go down again after data traffic has gone away. So as I said, in general, we like to put the hubs in a data center location. Now, with hierarchical DMVPN, that means I'm going to have a multi-layer hub and spoke network. So I'm going to have a set of spokes in a region connect to a regional hub, and then the regional hub connect to a central hub, and so on. So this is slightly, so now what I'm doing is I'm those spokes in the region may want to talk amongst themselves a lot, but they still want the capability of talking directly spoke to spokes in other regions. So by putting in regional hubs, in other words, an extra layer of that hub and spoke design, I can then group things. So that's another option way of doing DMVPN, or laying out the hub. A different thing comes out when I look at an ISP. So we have a number of ISPs, AT&T, Verizon, et cetera, that have offerings for DMVPN. So they offer to support DMVPN or create a DMVPN on behalf of their customer. Now in their case, they want to keep the hub in their network, because that's the control point for the DMVPN network. So they want to have control of that control center. So they want to keep that in their network, but it's no longer a data center. It's not a data point because their customer's data doesn't need to go through, isn't trying to get to something in the ISP network where the DMVPN hub is. And this is okay. It just means that for these style networks, most of the data flow is actually spoke to spoke. And they may actually set up in some cases, if they have a spoke to spoke tunnel that's basically up all the time because there's so much data traffic, we can actually under DMVPN manually lock that up so it stays up all the time. So there's many different things you can do. And then last here, mix and match. There's many times when I have different requirements for customers. I say, well, one single DMVPN design isn't going to fit it. But the nice thing about DMVPN, it's all virtual. It's virtual interfaces. It's virtual links. So I can actually layer multiple DMVPNs right on top of each other that are a little bit different. Maybe hubs in slightly different locations. Maybe one of the DMVPNs is a hub and spoke only for a particular purpose, but I layer another one on, on the same nodes that does spoke to spoke. I can do many different options that way. I can mix and match the DMVPN network types. Scaling DMVPN nodes. Again, the hub is a very important point of the network, and the main scaling point is the routing protocol. So once we bring up the spoke hub tunnel, I'm going to run a routing protocol like EIGRP, OSPF, BGP, RIP. We can run various different routing protocols. And actually, to scale the hub, how many spokes that a single hub can handle matters on the routing protocol. Okay, and we're going to look at that a little bit later in detail, a little bit more detail in that in just a second. So just keep that in mind. That's usually the most important factor. That's the most limiting factor usually for a hub is the number of routing protocol neighbors, because each one of the spokes out there that connects to it is going to be a neighbor. Encryption throughput is your second point. So you want to look at your aggregate encryption throughput. How much encrypted traffic is going to go through this hub? If it's a spoke, a hub and spoke, or a phase one DMVPN network only, that means all the spoke traffic goes through the hub, which means a decrypt, encrypt for each of the spoke-to-spoke packets. So you want to take that into account. Even if you're doing spoke-to-spoke tunnels, then there is a small time while we're building a spoke-to-spoke tunnel between two spokes where the spoke-to-spoke traffic will come via the hub. Didn't want to drop the traffic while we're going. Didn't want to drop the traffic in the time while we're building the spoke-to-spoke tunnel. So we run it through the hub so that traffic continues, and then when the spoke-to-spoke tunnel comes up, we'll switch that traffic directly over to the spoke-to-spoke. So basically, on the hub, there's a couple things to keep in track. How much spoke-to-hub traffic there is, in other words, data traffic that's going through the hub to get at a data resource behind the hub. Count that in. Some spoke-to-spoke traffic if you've got a phase 2 or phase 3 network. A little bit maybe extra, give yourself an extra 5% or 10% just to cover that. Now, if you're doing multicast on a DMVPN network runs on the spoke hub tunnels only. We do not run multicast over the spoke-to-spoke tunnels. So what happens is if I have a multicast source behind the hub, multicast packet hits the hub router, the hub will take that packet, make a copy of it, and send a copy to every single spoke out there. Or actually, it's a little smarter than that. It will send a copy to every spoke that has said via the multicast protocols that it wants a copy. So if I have 100 spokes out there, actually I think in this example, if I have 200 spokes that want a copy of a 256 kilobit per second multicast stream, that's equivalent to 51 megabits per second of encryption throughput and outbound physical bandwidth I need available on that hub router. Okay, so keep that in mind. We do support multicast, but it does put a load on the network. We're actually looking at some stuff where we may be able to reduce this significantly, but currently you have to keep in mind this sort of multiplication factor if you're going to run multicast through DMVPN. Now for a spoke, it's really pretty easy. In a spoke, you just figure out, okay, how much encryption throughput do I need in and out of this spoke? And you just size it to that. And so, and often on a spoke router, their actual physical link, maybe it only has a T1, 1.5 megabits per second connection. You don't have to have any more encryption throughput than actually 1.5 times 2, because it's in and out when we measure for encryption. So you would need 3 megabits per second of encryption capability on a spoke router to support that, for an example. So spokes, as I said, are pretty easy. You just figure out how much encryption throughput you need, size your spoke to be that big. Because in general, a spoke's not going to have that many tunnels. He's going to have 2, 3, 4 tunnels to hubs, and maybe a half a dozen spoke-to-spoke tunnels in general. there might be other sites. You might have a site that's maybe that's a data center, a secondary data center. That's not a DMVPN Hub site. You don't think it's, the DMVPN Hub site's at the primary data center, but this is another site. But it does have a fair amount of traffic, so you may want to stick a larger router there, maybe a 3945 or a 7200 or something there, because you know that a lot of the spokes, additionally to going to the primary data center through the main hub, are also going to go through the secondary data center to get some access. So maybe he has to support 100, 200, 300 tunnels. But again, because that secondary data center is a spoke, he's not configured as a hub, we don't have to worry about the routing protocol limit or the number of neighbors. So I think we're ready for another poll.
That's right. Okay, let's push it out to the audience. Great presentation so far, Mike.
Thank you.
Let's take a look at this second poll here. What is your preferred routing protocol to use over DMVPN? Is it EIGRP, OSPF, RIP or RIP passive, IBGP or eBGP, or you're not sure which one to use? Go ahead and take a moment to answer. Okay, let's go ahead and take a look at these results. EIGRP is the favorite. Okay, Mike, let's turn it back over to you.
Okay. So EIGRP is usually the one we recommend, not because Cisco's the only company that supports EIGRP. It's mainly because DMVPN builds out an NBMA, or a non-broadcast multi-access network, and a distance vector type routing protocol, which EIGRP is a better match to that type of network rather than a link state. But we do support EIGRP, OSPF, RIP, even ODR. We don't support ISIS because ISIS does not run on top of IP. So anyway, so let's look about. So we want to scale, and we're talking about scaling our hub router here with respect to our routing protocol choice. So we can look here. So we can look at it many different ways. And so the next 3 slides are going to say to look at this question in different ways. So I can say, okay, routing protocol based on scalability. Now, with an SLB design, this is a server load balancing design, and I'll get into that, what that actually is, a little later. But it's basically a way of dynamically mapping your spoke hub tunnels to a hub farm. So I have multiple hubs, and I can map them sort of dynamically. And with that design, we can go to many thousands of nodes. Okay. Now, each individual hub router may only support 1,000 spokes or so, but because I've got multiples of them, I can just keep growing my network. There's also a BGP using route reflector router farm design. We don't really use that too much anymore. We go with the SLB design on that. We can run RIP v2, RIP version 2 passive. You'd go, oh, what would you want to run RIP for? That's a pretty old protocol. It turns out it has one interesting property. There's a way that we can actually run it so that the spokes advertise via RIP their routes to the hub, but the hub sits there passively. He collects those routes and he puts them in a routing table, but he never advertises anything back to the spokes. By doing that, it lowers the hub, the CPU load on the hub significantly, allowing us to support more spokes. Then on the spokes, we use IPSLA, in other words, a mechanism to probe the hub and static routes. So if our primary hub goes down, then, if our primary hub goes down, then we can switch over to a secondary hub. Anyway, so we can see some of the numbers here. EIGRP 7200, 3945E is around the 750 mark. You can actually maybe push that to 1,000. On the ASR 1000, right now it's about 1,000 nodes. We can start pushing that up a little bit more. We are working quite a bit with the ASR team to increase our routing protocol scalability on that node. Notice BGP scales actually quite nicely, especially with the ASR up to 2,000. There was a bug where the dynamic routing protocol, dynamic IPsec, number of dynamic IPsec peers was limited to 1,000 peers, but I believe they have that fixed. So we can actually go above that for dynamic IPsec peers, which is DMVPN. All the IPsec peers are dynamic, the way it works. So that's one way of looking at it. Another way of looking at it is to scale the preferred routing protocol. So if you prefer BGP or RIP version 2 or EIGRP, you could stick OSPF in this mix too. You can use, so here's the different platforms you could do with these and so on. So you go look at your, I prefer using EIGRP. What platform should I use? And here's some of your numbers that you can see here. And then the next way of looking is that select a platform and encryption module. Okay, so here's sort of our encryption throughput. So this is the second part of that. The first part was more looking at the routing protocol, the number of routing neighbors we can support. Now we're just looking at pure encryption throughput. We can look at the ASR 1000. We're looking at 2 gigabits per second plus, depending on which module you pick. 7200 with the VSA, we're looking at about 500 megabits per second. 3945E, nice new device, coming in at about the same numbers. So you can sort of look at this and you can get a good feel for what to use. Again, with an SLB design, we can go to basically any number because what we're doing is we're just stacking up a farm of hub routers. So if I need to support 10,000 spokes and each hub can only support 1,000 spokes, I can stick 10 routers back there. To the rest of the world, they look like one big super router, but they're actually 10 individual routers, and I can get up to the support for 10,000 plus. I mean, I think we have some customers that have upwards of 20,000 nodes in their DMVPN network. So I think we're ready for another polling question.
That's right, number 3. Let's have a look. For what type of business do you need a DMVPN design? Small or medium business, a large business, home office or work access, franchise, point of sale or ATM, extranet, or ISP? Take a moment to answer. We need to get some polling music. Okay, let's have a look at these results. Okay, looks like large business coming in at 54%. All right, Mike, back to you.
All right. Actually, I think I missed a slide there. Okay, there we go. So I'm actually going to talk to this slide. This is actually just the text that goes with the next slide. I'm going to talk to the next slide here, network designs. So these are the base network designs for DMVPN. So talk a little bit about hub and spoke here. So that's a single layer, a set of spokes going to a hub, or of course, anytime I say hub here, I mean 2 or more. So that's what you see here, hub and spoke. Along with that is the server load balancing design. Now, so this is what I was talking about a little bit already, that we have the spoke connections come into a server load balancing node, which all it does is map those spoke hub tunnels to a farm of hubs behind it. That way we can scale very cleanly to very large numbers. spoke to spoke, phase 2, single layer hub and spoke setup, but I can build direct spoke to spoke tunnels. With phase 3, I can do hierarchical. I mentioned this a little bit earlier, where I can have like regional hubs that are then spokes of a central hub. The one nice thing about this is even if I have data resources behind the central hub, when a spoke wants to connect to the central hub, it doesn't have to go through the regional hub and then to the central hub to get there. It can actually build a direct spoke-to-spoke tunnel in this case, actually spoke-to-central hub tunnel directly into the central hub to get access to that resources. And then the last two are for network virtualization techniques, one using VRF Lite, and then one using 2547 over DMVPN, which is basically running MPLS on top of DMVPN. So two different techniques. The VRF Lite technique, this is for virtualizing. So what I want to do is I want to have a set of traffic like I've got, TAC and development and sales, and I want to keep them separate over the DMVPN network. I can actually build 3 DMVPN networks right on top of each other, one for each, and I can use that to keep the traffic separated. But let's say I've got 10 different types of traffic I want to keep separated over DMVPN. I might then run an MPLS VPN on top of DMVPN. MPLS VPN does my traffic separation. We then push it through a DMVPN tunnel so it's encrypted across the WAN and so on. So that gives you some of our base styles. And then we mix and match these as we need in a network. So sort of matching business to design here. I'm not going to go through these, all of these, but this sort of gives you sort of an idea of, okay, if you're a small, medium business, what type of DMVPN network would you probably build? Would probably match your needs. Small business, we're looking at DMVPN Phase 3 single layer design. Large business, you could go with a Phase 3 hierarchical design. You could go with an SLB design. Okay, again, many businesses I sort of mix and match depending on requirements. We do have capabilities for dial backup, multiple ISP connections, etc. This says 1,000 to 2,000 spokes. We can go larger than that these days on these designs. So home office work access. So CVO, Cisco Virtual Office designs. This is actually what Cisco itself uses so that its employees can connect into the Cisco network in a secure manner from their home. And we support, I think about 20,000 or plus employees coming in using this technique. And CVO, look that one up, www.cisco.com/go/CVO. And that uses DMVPN underneath. It has a couple extra things on to help make it deploy a lot easier, but it handles thousands of spokes. Franchise point of sale like ATMs, again, the server load balancing design. An extranet, maybe you want your business partners to be able to come into your network to access some database for them to use, but you don't want them talking to each other. We can set up the DMVPN network so not only is it hub and spoke only, they can only come into you, but we can also make sure that we block any traffic that would go from company 1 through your DMVPN hub out to company 2, so they can't reach each other that way. So an extranet design. ISP designs, talked a little bit about these before. Often they may want to bring in an SLB design network or MPLS into the network or VRS. So on this, so some of the different designs on that. One thing you notice here, I didn't say anything about DMVPN Phase 2. We're not getting rid of Phase 2. The networks support both Phase 2 and Phase 3. There's a slight difference the way you configure them to get Phase 2 or Phase 3 capability. We do expect over time that people will migrate. If they currently have a DMVPN Phase 2 network, they will migrate to a Phase 3. But as I said, there's no hard cutoff that you have to do it by this date. If it's a new deployment, then we expect you to go ahead and probably deploy Phase 3 directly. Here's the recommended releases. Not going to go through this, but this will give you the current, snapshot of the recommended releases. One thing you'll notice, I don't have, except for the 19, 2900, 3900 series routers, mention the 15 code. I still, I'm pretty conservative. I usually wait a while till I, recommend a good code. It's looking like the 15.1T code is looking pretty good. So I'm thinking I'll be able to recommend that pretty soon. But on the conservative basis, I stick back with some of the 12.4 codes on that. Okay, so I think that's about it. Here's some resources that you can get to, look at some stuff. That white paper I'm mentioning here is a white paper I originally wrote back in 2003. It actually only goes up barely into DMVPN Phase 2. And so, it's a good thing. If you don't know anything about DMVPN, it's a good paper to read through. It goes through all the basics. It is on my project list to update that, to bring in the new Phase 3 and the other stuff we've changed since then. But it is a good base paper to sort of get you, what's basically how DMVPN works. So I think that's pretty much it.
Excellent. Excellent. That's a great presentation, Mike. Hugely informative. Real quick, I wanted to make sure we let everyone know to make sure you fill out the evaluation, as the first 10 listeners to complete it will receive a $20 Amazon gift card. So make sure you do fill out those evaluations. It's a help for everyone here. And now let's move along into the question and answer portion of the event. Start out with our first question. This is from Kevin Miller. Hey, Mike, we've been using DMVPN version 2 for a long time. At Networkers, you talked about the benefits of version 3. Assuming my routers support the v3 code, is there any reason not to move to v3?
There really isn't. Basically, v3 is better than v2 in basically all respects. There's nothing in v3 that's worse than v2. I'm not forcing people to go to v3 just because I know that in a large network, it can be a little bit of work because you do have to go. I mean, there's some configuration changes you have to do to get there, et cetera. So in that case, you could stick with v2 for a while. As I said, I'm not planning to get rid of v2, but you will eventually want to go ahead and migrate to v3. Now, the best way to migrate to v3 is what I do is using the same routers that I've got out there, I build a v3 network in parallel with my v2 network. And then I can slowly move my spokes one by one to v3 without them, without having to take them down. So it's sort of a migration. Once I migrate all my spokes over to v3, then I can start tearing out my v2 network. In other words, you can have your v2 and your v3 network running in parallel. And to do that, I mean, you're going to play with the routing protocol metrics and stuff to do that, help you with that migration. But that's the usual technique I have for a large network. I don't like flash cutovers. I prefer more of a migration system.
Great, thanks, Mike. Let's move on to question 2. Is ASR currently supporting the DMVPN Phase 3 features? I've checked out the CCO documentation, and I have not seen anything that speaks to this. Can you elaborate? Okay, so that we're going to have to fix. DMVPN Phase 3 support on the ASR started in Release 5. I believe that's 2.5.x. When you look at it, but it's Release 5 of ASR, which has been out for 6 months or better now. We're actually up to Release 7 at the moment.
If you need to use DMVPN with front door VRFs, then you have to wait to release 7 or pick up release 7, which is out now, because that's where that support came in. But all the base code for phase 3 came out in release 5 on the ASR.
Great, thanks for clarifying that. Okay, let's move on to question 3. Mike, I have several DMVPN spokes. I'm sorry, I misread that. Can I have several DMVPN spokes behind the same NAT-enabled router with dynamic public IPs?
You can. There is one restriction. The restriction is that each DMVPN spoke must get a unique outside NAT address. Okay, we have to do NAT for them. You can't do PAT. Even though IPsec using IPsec is NAT aware and it can build out, it can handle PAT situations, NHRP knows nothing about ports or anything else. All it knows is about IP addresses. So the only way it can really differentiate spokes behind the same NAT router is if those spokes get a unique outside NAT address. So that's the one restriction in that type of setup. Okay?
Okay, great. Let's move on to question 4 here. Do I need the direct connection between hubs in a dual DMVPN dual hub scenario, or should those hubs be in different locations?
Okay, so when we're running with multiple hubs on DMVPN network, there is no requirement that the hubs be right next to each other. Okay, they can be situated, they could be in the same room, different buildings, different cities. That's up to you. You will need a tunnel connection between them. And except for a DMVPN phase 1 network, we can use a back-end LAN, multi-hop connection between them, and that's perfectly fine. But in any phase 2 or phase 3 network, we must have a tunnel connection between them. But again, that's just another DMVPN tunnel, which is easy to do. So physically, the hubs can be where it's best for you to place them.
All right, let's move on to the next question. And remember, you can still submit questions at any time. Just enter them into the box and hit submit. Okay, for hubs to support around 500 spokes, what's the recommended hub platform?
So actually 500 is fairly, that's supported by many different platforms. So as I said, the main thing on a hub is the number of routing protocol neighbors. Depending on the routing protocol, in fact, you're within the number that, let's say, a 7200, that's the one I'm most familiar with, easily support 500, OSPF, EIGRP, BGP, whatever routing protocol you want to pick on that will support 500. If you want to go a little smaller box, a 3945E is a great box. It's a brand new box, but it's showing to be quite nice for DMVPN. It's going to support around the same, we're looking at about around the same numbers, maybe 10% less than the 7200. So that's another possible box. If you need a lot more encryption throughput than those boxes could support, like you need in the 1 gig or up range, then I would probably recommend like an ASR 1000. And the reason for that is because we then have access to the very powerful encryption modules, the 2 gig and up modules from there. So you have, with that size, you have some choices.
Excellent. Okay, moving on to our next question. Is GetVPN over DMVPN a recommended topology?
In general, we don't run GetVPN over DMVPN. You end up with double encryption. Okay, now you can, there's a couple different ways of combining GetVPN and DMVPN. In fact, we're looking at methods inside Cisco to probably make some changes in the code to make it a little more transparent when you want to use GetVPN or DMVPN. But if you run DMVPN without encryption, you certainly can run GetVPN. In other words, you encrypt the data traffic with GetVPN, and then you just use DMVPN as part of your transport. The point with that is that your host addresses are going to be visible in the middle network. Now, somebody would have to get a packet, and they'd have to dig down in because they'd have to dig past the GRE IP header down into the GRE packet and then to find the IP header in there, and it would find its way down in to see those addresses. So in general, no. We usually recommend either building a GetVPN network or a DMVPN network, but you can do this. That would probably, something you'd want to come to Cisco, maybe an AS, to help out with to decide whether that's an appropriate design for you and what other options you might have for that. Okay.
Okay. Let's go and take another question here. In a 300-spoke DMVPN network over MPLS, how do I monitor the creation and deletion of spoke-to-spoke tunnels?
Okay, so monitoring spoke-to-spoke tunnels, we're improving that, and we've done some improvements in the last year or so. It used to be that the only way to monitor that was to look at the IPsec MIB and have it tell you when we're building, we're basically building IPsec encryption, decryption tunnels, because that's one of the things. When we build a new DMVPN tunnel, the first thing we do is call down into IPsec and say, IPsec, I need you to set up encryption for this. And that's the first thing that happens. So we would use that to get what we need. So you could use the IPsec MIBs to tell you. We have added some DMVPN MIBs so that you can actually have NHRP, you can actually query, and we just recently put out some traps, so we can actually tell you when NHRP is creating or tearing down tunnels. So that's probably your best way, using either the IPsec MIBs or the NHRP/DMVPN MIBs.
Okay, let's move on to the next question. Can we have an unequal cost load sharing riding on an EIGRP network with unequal dual ISP bandwidth subscription at the spoke router?
That's a tough one. I think I could probably design that. It might take a little bit of playing around. We certainly can set up, I have setups or designs where I have two ISPs, and I basically want to load balance my traffic across both ISPs. Now, in a DMVPN network, the best way to do that is actually I build two DMVPN networks, one that runs over ISP1 and one in parallel that runs over ISP2. And then I load balance my data traffic into the two different tunnels. That gives me the best load balancing across the two. The problem in this is there's an assumption there that the ISPs are basically equal and it doesn't matter which way I go. Now, I can influence the traffic going into the two tunnels by using the EIGRP metrics. I can say tunnel 1's better than tunnel 2, and therefore the traffic is going to use tunnel 1. And I can use some unequal load balancing under EIGRP to even that out. But it might be tricky to try to match that against the real ISP throughput capabilities or bandwidth capabilities, because that is sort of invisible when you're looking at the EIGRP running at the tunnel layer. So I think we might be able to do something. Now, do you support OER? So you can have OER running at the physical layer and basically run all your traffic over your primary ISP, and OER can say, well, this looks like it's getting a little loaded. Let me shift a tunnel over to the second ISP. Now, this is a tunnel-by-tunnel shift. So, we don't always know how much traffic is going through a particular tunnel. So that's another option. We can also run OER at the tunnel layer. So if I have my data traffic and I have a choice of tunnel 0 or tunnel 1, I can send everything over tunnel 0 and let OER shift some of my data flows over to tunnel 1. So we have a number of different options, and I think we'd have to play with these to get what you want.
Sounds good. Okay, let's move along. Got time for just a few more questions. Can I implement 802.1x port authentication with DMVPN? And if so, should I do it using the same phases 0 to 3 Cisco recommends on their Cisco.com site?
Okay, so we don't use 802.1x authentication with DMVPN. What I'm thinking is you're trying to run 802.1x on the tunnel interface to authenticate your spokes as they come into the hub. What we use is we use ISACAMP or IKE authentication as our authentication mechanism, so that a spoke is, as it comes in, the first thing that goes over between the spoke and the hub is going to be an ISACAMP session. And one of the first things part of that session is that the spoke has to authenticate with the hub. If he doesn't authenticate, then he can't bring a tunnel up. So that's what we use. So in that way, we don't really support 802.1x.
Okay, great explanation. Let's move along. Another question here. We are looking to do a fresh deployment of DMVPN as a migration from our dial-back solution. This will only be a hub and spoke solution. Hub is an ASR 1004, and the spokes are 2551s or 3845s. The primary circuits are EVPL or frame relay. Do you see this as a good fit for dial backup?
Yeah, this should be fine. I have a number of customers that are doing this. Now, one thing to keep in mind with DMVPN is that we bring up the spoke hub tunnels immediately, and we keep them up all the time. So the assumption is that there is no per minute charges for your physical path from the spoke to the hub. Now, if there is, I have done some techniques that for like let's say I want a DMVPN as a backup, or I have a primary MPLS network that I use, and I want DMVPN as a backup in case the MPLS link goes down. There are techniques now that we can do so that the DMVPN is all set up, but it's held in a down state. Okay, so no traffic goes over the dial backup link and then we monitor using object tracking or various different mechanisms. We monitor the MPLS path. When that path goes down or is not available anymore, then we trigger the DMVPN tunnel to come up. And it takes about actually sometimes it can come up within about 5 seconds. If we have to trigger up the tunnel, and then it has to trigger up the dial back, the physical link, et cetera, then maybe 20, 30 seconds, and it's up and running. And then when we switch back, the DMVPN tunnel will go back into a quiescent state or a held down state. So that's an option. I'm not sure if that's exactly what you're looking for, but those are sort of the things you look at when you want to do something like this.
Okay, I think that's about all the time we have today for the Q&A portion of today's event. Now, don't fret if you have additional questions or we didn't get a chance to answer your questions. Just head over to the Cisco Support Community URL that we have listed here. Mike will actually be on that forum, and he'll be answering questions on that site over the next 2 weeks. So be sure to head over there, and he can definitely elaborate on these questions and other topics. Also, I'd like to invite you to our upcoming webinar. It's going to be taking place on October 7th at 10 a.m. Pacific time. The topic for that event will be the Cisco Nexus 5000 and 2000 series, configuration and troubleshooting. Make sure to sign up today at ciscolive.com/ATE. We hope you enjoyed the Cisco Support Community Live Ask the Expert event and Cisco Live and Networkers Virtual. And we encourage you to explore the virtual environment, including the Cisco and partner booths in the world of solutions, the on-demand technical sessions in the session catalog, and the blog center. If you only have a guest membership as of right now in Cisco Live Virtual, you can upgrade to the Virtual Premier Pass, which will give you full access for only $395 US or 5 Cisco Learning credits. That's a great deal. If you're only looking for a few specific sessions, then we have an option for you as well. Our new a la carte pass enables you to purchase individual sessions for only $45 US. Also, if you have not explored the Cisco support community, please take a moment to see all this program has to offer at https://supportforums.cisco.com. Thank you so much to our expert, Mike Sullenberger, today for sharing his expertise.
My pleasure to help out.
Excellent. And before you sign off, please do complete the evaluation. You should see that coming up on your screen now, as this will help us address your business needs and interests in the future. Thank you, and have a great day.